Welcome. This is the first introductory video on how to build a homemade solar panel, and in this video we're just going to give an overall snapshot of what it takes to build a homemade solar panel, plus we're going to throw in some details about the system that goes along with it, and it'll be covered in a lot better detail in some of the other articles and videos in this blog. But right now we're just going to take a look at the big picture. Now, I will throw in that when I decided to start this project myself, I went out and bought some plans, and it was a great help to me. The reason that I did that is because I learn a lot better by watching someone else do it. So I picked some plans that had videos with them so that I could watch it be done. And then after I learned more about it, I decided that I would put up this blog and create some videos to help people kind of get the idea of what it takes to build a homemade solar panel, so you can start the process yourself. So let's get started here now. I want to start out by going to eBay here, because the heart of a solar panel is the solar cell, and this is the only part that I recommend that you just order instead of trying to make yourself, because this is the part that produces some energy, and it's made by other people a lot more economically than you can make it yourself. But there's something I want to point out here. There's a lot of solar cells available on eBay, and all you have to do is just shop around and find the amount and number of them that you want and bid on them. But I wanted to point out this right here. You see, this is 0.5 volts. That's half a volt, 8 plus amps, and 4 watts. Okay, now you're going to find that they're a lot the same, especially voltage wise, in one cell to the next. There are going to be different sizes, different shapes, different amperages, therefore different wattages. So let me just explain that just a little bit to you. This is just a little note sheet I wanted to put up with some details on it that might be important to you. First of all, this is an electrical formula that tells us that volts times amps equals watts. So that'll help you as you're shopping through there understand what they're talking about. But that one was a half a volt. It was 8 amps, so it equaled 4 watts. Now also, DC current is direct current, like your car battery or your car system, where AC is alternating current, like your home uses and your refrigerator runs on. So what we're going to talk about in this video is how we start out with DC current like a solar cell makes and end up producing AC current so you can use it in your home. Here's a little fact: wiring in series, and you'll get more information on this in other videos, but we go positive to negative, which adds up the voltage. Okay, and then wiring in parallel, we go positive to positive and negative to negative, which adds up the amperage. Now what we're shooting to do here is produce a solar panel that produces 18 to 20 volts DC to charge a 12 volt battery. Now that may seem a little strange that you would produce this much voltage to charge a 12 volt battery, but think about in your car, your alternator is capable of producing a real high voltage, but it has what's called a regulator in it that only lets it produce a maximum of 14 volts. So they use a 14 volt charge to charge a 12 volt battery. So this is just not uncommon here. This is something that is kind of normal in electronics. So now let's talk a little bit about the DC current and AC current, so we can understand that a little better. This is Wikipedia here, and this red line represents direct current. Okay, that is like your car. And so let's say that this red line represents 12 volts right here, and it just stays constant. Whether it's flowing from positive to negative or negative to positive, it doesn't matter. It stays constant. Okay, it never changes. The green line, however, represents AC current, like you might use in your home, and so it starts at the baseline, goes to a positive peak, then to a negative peak, and then back to the baseline, and this is one cycle of electricity. Now in our country, our standard electricity, this happens 60 times a second. Okay, and so all your products in your home are made to run on 60 cycle electricity, and that's what's happening there. So what we're going to talk about here in this video and more in other videos is how we're going to change this direct current coming off the solar panel and out of the battery to alternating current so it can be used in your home or shop. Okay, now let's take a look at a solar panel here, and this is a graphic off of Google. I love that Google. And this is a real good graphic because it shows kind of how a solar panel is made. And ours doesn't have to be as sleek and pretty as this one is. This is kind of like a factory model, but it shows the parts. This is a shield that goes over the top, which can be glass or really better plexiglass, so it's strong and resilient, and it protects the solar panel. Okay, then these are the solar cells like we looked at on eBay. Now if they all produce half a volt and we want to produce a total of 18 to 20 volts out of the panel, we're going to need about 36 to 40 of these things mounted on a piece of backing and tied together in series to produce that much voltage. So that's why you see all those different solar cells on there. And so you're just going to order enough to produce the kind of voltage you want. Now if you're just doing a home kit, some kind of a little project for school or something like that, you might only need just a very few cells, and maybe you're just going to run a LED light with it. So all you need is enough voltage like a flashlight might produce, so you just need a very few solar cells. If you want to produce enough to charge a car battery, you're going to need more. Now this is the backing here, and that's what we're going to mount our solar cells on. And if you were just doing a small project, you might just use cardboard. But if you are going to make a solar panel to use around your home or shop, a piece of plywood is fine. And as you build one, and maybe you build a second one or a third one, you might get real fancy with the materials, but for simple and cheap, just a piece of plywood will work fine. And you can use silicone sealer like you might use on your bathtub that you can buy at the hardware store to stick the solar cells down to the backing and keep them in place. And so this is the great lesson with building your own homemade solar panel, is these cells are the only thing that you have to order. You should order those, and you can get a good deal on those if you look right. The rest of the parts can all be bought right close to home and downtown. This around here is just a frame, and it just kind of holds everything together. And really, if you want to make one out of wood, you could just use a piece of pine lumber around the edges, you know, to attach the backing to the cover. And you can seal it all up with silicone. You can paint it. This is where your mounts are going to go, either on the back or on the sides, to mount it to whatever that you mount it on. Okay, now we're talking about mounts. If you're going to mount a panel out by itself, maybe to run a fence charger or something like that, a lot of people use a pole mount. And if you notice, it's got to be sturdy enough so that this panel, if it catches wind or weather, it's not going to like knock the pole down or break the mounts. Okay, so everything's got to be sturdy enough for that, maybe set in concrete and oriented so that doesn't see any trees between it and the sun, gets full sun during the day. And this mount here, of course, is adjustable, so during the different seasons you can kind of adjust a little bit if you want, and then it's going to just hook out to whatever you want to run with it. Now this is a real good graphic, I think, and it shows a more popular type of, like a roof mount. If you notice on this, they're mounted up off the roof just a little bit, so it allows for ventilation, dissipates the heat from the panel, and they're good and sturdy so that they're pretty weather resistant also. Now this is a way to mount an array of panels out in the yard, out away from a building. Good strong mounts set in concrete, all set up so it'll handle weather, and your wiring then probably just go underground and right out to your load. Now this graphic here just shows more about a system, and this is the part I was telling you about where we're going to change the type of electricity. The sun puts out solar energy, the solar panel collects it, and electric current comes out. This is DC current at this point. Now this charge controller is just about like the alternator has the regulator in it that keeps it at 14 volts. So that's what this controller does. It keeps it at a good voltage then to supply a battery system. Okay, so your battery can go over here. It could just be one battery or it could be several, but this battery is important. If it's just a little project, just any little car battery will work. Okay, a 12 volt is fine, 12 volt car battery. But if it's a system you're going to use for any length of time, these need to be deep cycle batteries, because a regular car battery won't hold up very long. So you might buy these are built for an RV or marine use. They're called deep cycle batteries, and so that's what you're going to want there. And then the 12 volt DC comes out to what's called an inverter. Now here is where we change DC current to AC current coming out, and you can buy simple inverters down at the farm store, and they wire right over to a battery. They'll have little plug-ins right here, and when you plug something that runs on 110/60 cycle for American inverters, it's going to run them just fine, and you can get them in different sizes for different loads. You can, of course, get them bigger for bigger jobs, but that's basically how all systems work right there.